This video is on law of sines and cosines. This is example 3. This is a triangle that we do not have the angle measurements for, but we can determine if this is a right triangle or not by classifying it. We have 11, 14, and 19, and we can check to see our two smaller sides. So 11 squared plus 14 squared is 317, and then 19 squared is 361. So our c squared is bigger, so this will be an obtuse triangle. That means that we will have to have an angle in here that is bigger than 90 degrees. So we know that this is not a right triangle, so we need to do law of sines or cosines. So to determine if I need to do law of sines or cosines, I'm going to make my chart that I plug all of my information into. So my 2 columns for my angles and sides, and my 3 rows for A, B, and C. So I'm going to have angles big A, big B, and big C, and then little a, little b, and little c. So on here, I actually have no angles. I have 3 sides. So here's big A is across from 11. So 11 is your little a. Big B is opposite of little b, so 14 is little b. And big C is opposite little c, so little c is 19. This actually tells us, since we know our sides will create an obtuse triangle, we know that our smallest angle is across from the smallest side and the biggest angle is across from the biggest side. If the biggest side is 19, then this angle right here, big C, has to be the biggest angle, which in this case, since it's an obtuse triangle, it has to be an obtuse angle. This angle must be bigger than 90 degrees. So if we see that we do not get 90 degrees or higher, or actually higher than 90 degrees on angle C, then we know we did something wrong. We also know that 11 and 14 will have smaller angles, so A should be the smallest angle that we should find. So in this case, we need to do law of cosines because we do not have an angle and its opposite side. We have nothing that matches. So we need to find one of these angles. Little a is the smallest, so let's go ahead and find big A, which should be the smallest angle as well. So if we set up for our law of cosines, if we're using little a in the beginning, we're going to have little a squared equals b squared plus c squared minus 2bc cosine of big A. So again, B and C, little a is in the front, A is in the back. So let's plug in what we have. We have a squared, A is 11, so we're going to have 11 squared equals B is 14 squared plus C is 19 squared minus 2 times B is 14 times C is 19 cosine of big A. We do not have big A, so I put big A. Now this is really important to be careful on. You cannot plug all of this into your calculator because this is not all addition and subtraction. This 2, 14, and 19 are all multiplied to the cosine of A. So you cannot just put this part into your calculator. So 11 squared is 121 is equal to 14 squared is 196. 19 squared is 361. And then we have 2 times 14 times 19. So 2 times 14 times 19 is 532. So this is minus 532 times cosine of A. So we have 121 on the left, 196 plus 361. We can add those because there's no multiplication attached to it, but we cannot subtract 532. So 196 plus 361 is 557. So we have 121 is equal to 557 minus 532 times the cosine of A. Now to solve for A, I have to subtract this 557. So 121 minus 557 is negative 436 is equal to the negative 532 cosine of A. Now in order to get A by itself, I'm going to have to divide by the negative 532. So I'll have negative 436 divided by negative 532. And I get a decimal. However, I don't want a decimal. I want to do math, fraction. So I get 109 over 133. I could have actually kept it as 436 over 532, which is perfectly fine. So I can actually do that. I know that the negative divided by negative will become a positive. So I'll have 436 over 532 is equal to cosine of A. To solve for A, I have to do the inverse of cosine so I can have my angle. So let's just take the inverse of your fraction. So our A value that I'm going to be able to plug it into the calculator, A is going to be the cosine inverse of, just type in your fraction, of that positive 436 divided by that positive 532. So when I type this in, I do second cosine of that 436 divided by that 532, close parentheses. Again, A is roughly 35 degrees, because if this rounds to the nearest tenth, the 6 makes the 9 go up to a 10, which does end up making that to a 35. So A is approximately 35 degrees. A is approximately 35 degrees. Now, it was supposed to be an acute angle, so far we're good. So this is 35 degrees. Now that we have an angle and its opposite side, we can go into law of sines. So if we go into law of sines, we will need to use sine of the A's, sine of A over little a, because this is the information we have. So we have sine of big A, which is 35 now, over little a, which is 11, is equal to. Now to figure out which one we want to use, on the last example that was in a previous video, we decided to use the bigger side, and we ended up getting an ambiguous case. So this time, let's use the smaller side and see what happens. So let's solve for big B, and then determine to make sure that that is still an acute angle, and then we can solve for big C. So let's do sine of big B over 14. So on this one, we are going to cross multiply. So we will have 14 sine of 35 is equal to 11 sine of big B. In this case, we will have to divide by 11 to get the sine of big B off of it. But just like over here, we had to divide, but then we ended up doing the inverse of our cosine. So here we'll divide and do the inverse of our sine. So we can actually type that into our calculator. So big B will be, so we'll have to end up taking the inverse sine of the entire thing. And then we'll just type in the actual fraction. So this would be our numerator, the 14 sine of 35. And then our denominator would be 11. So I need to close my parentheses after that. So now, typing this in, hopefully this will be an acute angle, and it will be bigger than 35, because 14 is bigger than 11. Hopefully it'll be bigger than 35, but not an obtuse angle. So we'll have second sine, which is sine inverse, of 14 sine of 35, close parentheses, divide by 11, and then close parentheses again. This is bigger than 35 degrees, and it is still an acute angle. So this is 46 and 9/10 degrees. So angle B is approximately 46 and 9/10 degrees. So I can put that in our chart, 46 and 9/10 degrees. Therefore, we can solve for angle C because we know that the angles have to add up to 180 total. So we have 35 degrees already, roughly 35 degrees, plus the 46 and 9/10 degrees. So we have 81 and 9/10. We're going to subtract that from 180. We'll get 98 and 1/10. That is an obtuse angle because we were going to have an obtuse triangle. And that is also the biggest angle because it's opposite of the biggest side. So this is 98 and 1/10 degrees. We had to solve for all of these angles. This was a side type of problem, so that told us we had to do law of cosines anyway. But once you have law of cosines, once you've used it, you have an angle and its opposite side, you can go into law of sines. And we could generally go ahead and use the smaller of the sides when we do the law of sines. After the law of cosines, use the smaller of the sides to find your angle instead of the bigger. The last time we did the bigger one, it was an ambiguous case. Doesn't mean it will always happen like that, but it's always a good idea to figure out which one to use first. But since we did law of cosines and then law of sines, we do need to always double check. Your smallest angle is A, and your smallest side is A. Your largest angle is C, and your largest side is C. That tells us that yes, these do match, so medium would go with medium. So this is the correct triangle, and this is our correct information.